All right, today, continuous random variables. All right, so continuous simply means that you can have any value. So to have any value to keep in mind is if they're measured. So for our discrete random variables, are things that you would count. Continuous things that you can measure, so examples might be height, mass, and so on. There's a whole heap of different ones. So what that means is if it's continuous, then we get a graph of the probability density function that will be a curve like this.
You should have come for that.
I would do it on this. I reckon the word continuous is the worst. Why did they spell it like that? Just no other words have a like a U-O-U.
U-O-U? I know,
Just
it's
sucks.
just silly, isn't it?
It's just, English is just stupid, isn't it?
Yep. Alright, so it's a curve. So if we have our probability density function, fx is our probability density function, then it will be a curve, so it would look something like that. Doesn't have to look like that. It can look a number of different. So if we want the probability, know the probability of getting certain outcomes, then the probability is the area underneath. So say for example, I've got outcome A and outcome B, and I want to know the probability of getting between those two, then what I'm looking at is that area there. So the probability is where we use some calculus. And the probability is given by the integral. So the probability that our outcome is between A and B will be the integral from A to B of whatever our function is, dx. Right. Now there's a couple of things.
Is that a big X or a small
What does
X?
PDF stand for?
Probability density function,
Oh yeah, of course.
not
And-
portable document format.
Yeah.
That X
This X here is the little one.
and the one in
This
the
one here is the
big
the
one.
big one.
Okay. PDF is also.
All right, so
What's the what?
They're always equal.
for this curvy thing here to actually be a probability density function, there's a couple of things that it has to have. First of all, probabilities, you can't have a negative probability, so it's always got to be above the axis. So that's one thing. And the other thing is, if you put all the probabilities of all the outcomes together, it's got to equal 1. So this area that's in here has to equal 1. So you can't just have any function, fx, it has to satisfy those two requirements. So probability density function, the following conditions. Apply. So first of all, as I said, can't have negative probabilities, so that area's all got to be above or on the axis. For all x, and the other thing is that the total area has got to equal 1. Just remember the total area, or the area is underneath is the probability. So this area here is the probability of getting an outcome between A and B. So if you like, the integral from the bottom end to the top end, whatever they are, it's got to equal 1. Now I've got negative infinity here. That doesn't have to be those, and I'll talk about that in a minute. All right. Let's have a look at an example.
That's really wrong. Probability in calculus. We're discussing with baby. Did you use calculus to find probability?
How does nothing use maths?
In methods?
Just methods, no maths.
It should be seconds,
Can't we
not
just match the
seconds.
pretty shapes to the pretty holes?
No. We're 18. One of those wood shapes through those quite kitty ones. Good math class when you go around the lab, unfortunately.
I have a,
Shapes
filled
filled
with that. I have to put every single shape through a hole in every dimension.
Glenn,
Yes?
I still don't know how to feel about the way you're talking about my brother.
Just saying he's a fine specimen of a man. Like I just saw it, I was like, he is like firefighter, that should be like on a firefighter calendar, like, he's like a stereotypical. Like in reality, most of them are like middle-aged men who have nothing better to do than firefighting. But he's like, when you picture firefighter, like, your brother is what's Prince to me.
That's weird.
That is very cool, Glenn.
I know. He's a firefighter.
He's a five.
Yeah.
Nice, okay.
That's why I said your brother is a
Well,
firefighter.
he makes it clear out of it. So he does want to do it, he also does I mean, if you want a meeting, Glenn, have an informational session soon.
You can get some information. Are you suggesting
Glenn,
that Glenn hooks up with your brother?
No, he's just. I mean, I don't think that's where he was going. I mean, he was.
I think he was doing a bit of a shameless plug on Google. Be a volunteer.
That's what I thought too. Blood pressure mild emergency. Yeah, this thing makes me fireproof. It's already so hot.
I feel like
It's
you.
because nothing wants to touch you, man.
All that.
All my 14 subscribers would be distracted by the conversation
You might get the
from the mathematics.
That's pretty hard,
Are we up to 14 now? That's a
Up to 14.
nice.
You missed that news yesterday.
Because you weren't here yesterday, Glenn. You missed out.
Probably half of them are the subscribers.
12 seconds seems. I mean, what pieces is this puzzle?
All right. So our solutions. Let's have a look. So find the probability it takes less than 12 seconds. So that's the probability that x is less than 12. So if we're doing this, and remember the probability density function is this, and so it's the area underneath this function, which
Sorry
is
to interrupt. Would you be able to have a student on?
sure.
Great.
We can do that. All right, so 5 on x squared dx. Now, these numbers on there we need to have a look at. Now, this probability density function of 5 on x squared, the bottom end of it is at 5. So for this, our lower number here is going to be 5, because when x is less than 5, probability is 0.
Oh, so it has to be less than.
So the lowest that we can go is 5, and we're wanting less than 12 seconds. So the number up the top, less than 12 seconds, the number up the top is a 12. All right, so the 12 comes from there, and the 5 comes from there. All right, so then we get our calculator out, come up, and then we get our thing there. We got 12 up the top here. The lower end there is 5. Our function is 5 on x squared, and dx, and we get our calculator to calculate it for us. So it's 0.583, and if we want it, of course, as a fraction, we'd have it in standard, and it would be 7/12. Although I'm not told there. All right. Could do that by hand. Okay, part.
This is it.
Yep.
If it's less than 12, how come the bottom is 5? Like, wouldn't you have to add the one where x is less than 5 as well?
Well, I've just rubbed it out, but it was 0 there, wasn't it? So that's why I didn't go lower than 5.
Yeah.
From that, I would assume this puzzle's hard, and it's going to take everyone more than 5 seconds.
It's not hard.
Oh, it's not
What kind
hard.
of puzzle?
It's an easy puzzle. All right.
5 seconds.
Well,
It would be quick to solve like a jigsaw, but it would be slow to solve like a...
all right, so the next bit says the probability it takes between 8 and 10. So that's between 8 and 10. Given, so this given is our key word. Given indicates what sort of probability?
Conditional.
Very good. And that's a vertical line. Given that, x is less than 12. So we've already worked out the less than 12 bit. All right, so conditional probability equals.
For where A intersects B over the
Yep.
probability.
So 8,
So you're gonna say like all of a sudden.
that intersects that.
Hearing conditional probability was shocking.
over the probability that x is less than 12. So bottom line we've already worked out. Now let's think about this. What would that intersection be? So if I just draw a little, this is our x and here's 12.
Is it 9?
So x is less than 12 is down that way. Between 8 and 10. So here's 8 and here's 10. Between 8 and 10 is that way.
So it would be.
So the intersection is simply that bit I've got in orange, isn't it?
Yep.
So more simply, the intersection is just the probability that x is between 8 and 10. May not be always be that case, but in this problem, because the 12 stretches all the way through. All right, over the probability that x is less than 12. The top line there, well, the top line is between 8 and 12 of 5 on x squared, the x. The bottom line is what we've just already worked out. Which is 7/12. So whack the top line on the calculator. Let's just change these.
Is that 12 meant to be a 10?
Where?
Yeah.
10, yep. Correct. 8 and 10, not 8 and 12. Just change those. 8 and 10. And the calculator says that's 1/8. So we've got 1/8 divided by 7/12. So we're dividing by a fraction, we
Flip and
One.
time both.
flip and times, yep. And then we do some cancellations. 3, 2, 3/14. Right. The next, the mean.
I really said that I'd type that big. I think we should use some paper.
I'll rub all that off.
Go for it. Oh, Jake. So, Jake, you can copy mine. So
Okay.
Really weird flag on.
I feel assaulted.
You like have something more like.
All right. So the mean, or the expectation value, which of course is mu. So
Just having the water as well as
More than a bit. Look at
So
that.
previously with discrete ones, to get the expectation value, we multiplied by the outcome by the probability of that outcome, and we added them all up. Well, we do the same thing, but the way we go about doing that is slightly different, because the probability, remember, is that area. So for continuous random variables,
is this?
that then becomes mean, which is
15B.
the expectation value, is the outcome multiplied by the probability, and the probability is given by that integral. So it's the same thinking behind the discrete, just the way that we work it out is different. So, for example, so here's our probability density function. And so it's 0.5x when x is anywhere between 0 and 2, and it's 0 everywhere else. Alright, so again, related to Alice's comment before, the everywhere else at 0, we don't actually need to consider that at all, because the area between that line that's sitting on the axis and the axis, there is no area there. It's on there. So we only need to consider these x values. So our mean, or our expectation value, is the integral. So expectation value is the integral, and the integral in this case applies between 0 and 2. So that's where our function is between 0 and 2. So there are our limits. X times our function. Alright, and our function is this one here. That's what I'm going to put there. Dx. And again, we get out our calculator and put it in. So 2 up there, 0 down the bottom. And the thing we're doing here is x times 0.5x dx. So the expectation value is 4/3. So whatever this thing is, you would expect to get 4/3 as the result. Now you can actually find the expectation value of a function. Which seems like a strange thing. We can do that. So let's look at that.
Does Jordan take?
Yeah.
And to get the expectation value of a function, it's very similar to this here. Rather than having that x, you put in whatever your function is. So the expectation value.
Well, we've got a subhead.
Yep. Of say gx would be, so the expectation value of gx, again, is that integral from negative infinity to infinity, or whatever the end points are. Instead of just x, it's g of x, whatever that function is, times the probability, which is our f dx. So, example. Pen's dead. Alright, so it says for the probability density function in the previous question, so that's the 0.5 x between 0 and 2. Find the expectation value of e to the x. So the expectation value of e to the x is the 0 to 2 times by that function dx, the probability density function. Because we're finding e to the x, what goes here is the e to the x. Alright, so again we can get our calculator out. Let's change that there to e to the power of x. And then you get this very interesting exact value, which is e squared plus 1 over 2. Or if we did it in decimal, we would get that. Alright, two more things that aren't connected with each other.
Is it what? Why am
I don't know, I can judge your facial expression.
I was saying was really smooth, so it's like,
Alright, percentiles. This is another subheading.
So this all, this two bits have been 15b,
A and B.
and b, yeah, well the first bit was a later.
Yes,
Missing
first. Yeah, and these a bit. Alright, so the percentile is just the point where a certain percentage is below. So percentile is the score. Oops, the score below which a certain percentage. Alright, and that's in fact what your ATAR score is.
Yeah.
If you get an 82 ATAR score, it means 82% of people are below you. Alright, so the way that we would figure it out, the probability that x is less than or equal to, call it p, some value.
What do you think about that way? A 58 doesn't not that matter. That means 50% of the state did worse than you did.
And it makes you feel bad because 50s are perceived as bad.
Yeah.
That means
we
that
don't
like
care.
65 to 70% of
Yeah,
a
you're
single
technically-
student is just stupid.
Like
Off the bat.
a 75 ATAR is like you're better than 3/4 of the state. Exactly, like that's not.
But that's not how it works.
75 average.
I was so happy about
I'm
the
still like
75.
a really good.
I think like it's 65 or 70 is about average.
I feel like 65.
I reckon if I get below 65 or a business corner, but above
Yeah.
that I'll be happy.
It's like everyone's
Yeah,
greatest
well, and
achievement
it's
is
just
just
above
like riding up
65.
the back of people who like go into trades and stuff. You're not that smart, you just like
Alright, so p is the value, whatever that value is, where q as in the decimal, so if it's 80 percentile, it's 0.8 and so on, are below, and p is what we're going to find that particular score. So let's have a look at an example. The length of calls, this is the length of calls. Has the PDF. And here's our PDF, f of x. 1/3 e to the negative x over 3 when x is greater than 0. So I'm supposing x is representing time here. And it's 0 when x is less than or equal to 0. So I guess, you know, not got a call that's more than 0 seconds, you've not got a call, have you? Right.
Telemarket calls.
Negative 5 seconds.
Alright.
You start.
If you pick it up and you don't hear someone talking instantly, it's just... Pick up the phone.
Or you hear like the sound of it kind of clicking off somebody.
Yeah.
See, like that.
Alright.
We should one time.
So here's our probability density function. We want the length of the call at 90% or below. So 0.9 is the decimal equivalent. So this Q here is going to be 0.9. So what have we got? Well, the bottom end of it is 0. The top end, we don't know what it is. That's what we're trying to find out. The function probably is 1/3 e to the power of negative x over 3 dx, and we want that to be 0.9.
Why, though, why
Yeah, same.
the negative x over 3, why isn't that, it was not that.
What was
up
it? Where am
top.
I?
It was negative x
Oh,
over x.
that's not correct, is it? It's negative x over
Okay.
3 over 3. Sorry, my bad. Alright, so that's going to be tricky to do. Good news is our calculator is handy. So if you go calc and then you use the solve function, stick that in there and ask it to find p, it will do it for you, although you might want to use a different letter other than p. So we'll go solve, math 1 is solve this integral for me from 0 to, I'm going to use y up here, it's on the keypad, of what? It's 1/3 e to the power of, use my template up there again as well, x over 3 dx, and I want to find y. And so you go,
You need equals.
oh, thanks, I do need equals. Equals 0.9 will help, won't it? That's better. So that means that the score, or the length of phone call, 6.90
So that's how long phone calls you get 90
78 seconds or minutes or whatever it is. 90% phone calls will be less than that length of time. All right. Now the next bit, the last bit, is related to this. It is a percentile, but it's a particular one, and that's the one in the middle. It's the 50th percentile, and that's given a special name. The thing in the middle is called the median. Very good.
Yeah.
So it's just whatever it is equals 0.5.
Yep. All right, so the median is the 50 percentile.
I understand on that.
So
You said it's like 100.
the bottom end to wherever the median is, fx dx, 0.5. That tells you exactly where the middle is.
Yeah.
Let's do an example.
I certainly do remember Miss Hooper. She didn't like me.
What if she watches this?
I mean, good on her if she does, but I'd say she would agree that she didn't like me. Folks, they do a lot of talking and not much writing. Me or her? It was Henry and Blake and TV and Amy as well.
I know.
And Ruby.
Alright. Oops.
Oh no, Amara.
Alright, so this time our median, we've got to use this here, so the lower end, is 0, up to wherever our median is, that's what we're going to find out. Our function is 2 bracket 1 minus x dx, and that equals 0.5. And again, we stick all of that in our calculator, solve. For M, I'm going to use P on the calculator. No, I'm not. I'm going to use Y on the calculator, not P. Where are we? Maths 1. Solve. What am I solving? I'm solving that integral. The one from 0 to, going to use Y. Of the function, which is 2 bracket 1 minus x. Dx,
You've got the equals again.
okay,
You've got the equals again. Oh, there.
equals 0.5. And tell me what y is, please.
Please.
Well, you don't need the please, but
Both hopes, I'm sure.
it's nice.
Yeah.
So it gives me 2 answers. It tells me that the median is 0.293,
Is that Lara out there?
Yeah.
Nice.
or it tells me that it's 1.707. Anyone notice anything about that?
So there's 2 medians. One of them is outside the
Yeah.
restriction.
One is outside the, so up here x is between 0 and 1, this one's outside. So cross it out because it's not in our domain. So if you get a couple of answers, check, make sure that they fit with our domain. If they don't, you ignore them. All right.
Why did we get 2?
I mean, this, if you graph this, you get a whole long, so the mathematics, as far as the mathematics is concerned, this is like continuous, keeps
Yeah.
going, but we've restricted it down to just one portion of it. So, you know, the area between 0 and whatever that is, of being 0.5, there's 2 places where that area could be 0.5 between 0 and, because some of it might be, because so that line here will go something like this, and so we're going between, we want an area of 0.5, and so what we'll do is go, okay, well, that area there is 0.5,
Okay.
and then because the math, when you do an integral, the integral itself can't tell the difference between positive and negative, so it'll go, well, up here, we've got all of this, take away this and the answer's 0.5.
Okay.
But we're only, for the purposes of the probability, we're only looking, you know, in here,
I see.
which is probably up to there, I'd say. That'll be 2. So we're only looking at this part. So in this part, that's the bit there where the area is 0.5 and that's 0.29. Yep. Answer the question?
Is that
Good.
all?
Thank you.
Is
That's
that
it.
That's it. 15A and 15B.
15A and B.
My second question.
Sweet, so-
And we have 5 minutes left, guys.
That's great.
No, that's-